Lesson 4, completing the square. So the turning point of our parabola and its general shape are relatively easy to determine if our function is written in shifted or vertex form. So as a reminder, that shifter or vertex form is y equals a times x minus h squared plus k. And remember that the a determines whether the parabola smiles or frowns, and it tells how wide or how narrow our parabola is going to be. And the h and k is our vertex or our turning point. But what happens when we're given an equation that's not in vertex form? And we still need to find the vertex. Maybe just looking at the equation and not having that ability to graph it to see where the turning point is. So let's take a look at exercise 1, where it gives us an equation and it says give the coordinates of the turning point. Well, that is clearly in vertex form, so we know that our turning point is going to be 3, 2. Or in other words, from the parent function, our parabola is going to be shifted to the right 3 and up 2. So this serves a couple purposes. All right, that's our turning point or our vertex, okay, depending on the terminology that you use. We also talked about that number there, the x value, is also the axis of symmetry. And it also tells us the shift of our graph. So from the parent function that had its vertex at 0, 0, it tells us that our function has been shifted right 3 and up 2. So a lot of information you can pull from just that small little tidbit there of the turning point being 3, 2. Now it says determine the range by drawing a rough sketch. Well, we talked about right here in the beginning that that number in front of the parentheses, whether it's positive or negative, determines whether it smiles or frowns. So when we look at our equation, we know that it's a positive 1. So we do know that our, just sort of a quick little idea here, we know that our parabola is going to open up. But now even more specific, we do know that the turning point is at 3, 2, okay? Real rough sketch of that. I don't really know, looking from that equation, where the y-intercept is. So to determine the range, if we know that this point is our minimum value, so that's the lowest point, and then it goes to positive infinity. So our range would be y is greater than or equal to 2, or if you wanted to put it in interval notation, you'd say 2 to infinity. So looking into this next section, it says the question then is, how do we take a quadratic equation in our standard form and put it into its shifted form? And we have a process known as completing the square. So we've got to kind of build up to this process. So if I were to take and write each of the following as an equivalent trinomial. So right now, what does squaring something mean? Well, in this case, squaring something means multiply it by itself 2 times. So when I go through and I double distribute, eventually when I combine like terms, this is what I would end up with. In B, again, double distributing, I'd end up with that. I'm doing these pretty quickly because you guys right now are very good with multiplying or double distributing. And this one I'd end up with x squared plus 8x plus 16. So we had to think about and review, what does it mean to square something? Okay, multiply it by itself. Now it says, given each trinomial in exercise 2 in our standard form. So right now, our 3 answers are in that standard form. So what's true about the relationship between the coefficient b and the coefficient c, or the constant c, I should say. So b, whoops, I shouldn't do that color because we can't see anything. I'll underline it. There we go. B to c. So what kind of relationship, what kind of pattern do you see? and then B to C in this one, and B to C in that one. Okay, so it does take at least 3 examples to maybe be able to pick up some kind of a pattern. So if we look at and examine exercise A, our B is equal to 10. But if I took half of B, I'd get 5. And then if I took that number, that B over 2, and squared it, in other words, 5 squared, that equals 25. So right now, I did something and I found kind of a funky relationship. That wasn't one that just kind of jumped out at me initially. And it's taking half of the B, squaring it, and that's equal to your C. Well, let's see if it holds true in example B. So if we take, we know that B is -2, but if we take half of B, that gives me -1. Okay, if we take half of -2, that gives me -1. And then if I take that B over 2, or half of B, and square it, what is -1 squared? And that's +1, which is in fact my C. So that's the relationship. To sort of summarize, half of B squared, okay, half of B, and then square it, is equal to your constant, or C. So we've just sort of looked at 2 examples that are going to eventually get us to completing the square. We got to look at one more example, and you'll start to realize that the process of completing the square is sort of labor intensive, but once you get the hang of it, once you understand the process, it really becomes a recipe that you're very fluent with producing. So each of the following trinomials is a perfect square. Write it in factored or perfect square form. So, okay, so again, some verbiage there that we need to think about. And if I take this first one, and my coefficient's 1, there's no GCF, I can go right to sum and product. So 2 numbers that multiply to 100, but add to 20, that's going to be +10 and +10. Well, this is a binomial times itself, so they're asking us to write it in perfect square form. Well, that's what that would be in perfect square form. So part B, again, no leading coefficient. We don't have a GCF. Go right to sum and product. So 2 numbers that multiply to a +9 but combine to -6 is going to be -3 and -3. That's going to be x minus 3 squared. So in this last one, sum and product, x plus 1 and x plus 1, and I could simplify and write that in its perfect square form. So hopefully exercise 2, 3, and 4, we touched on some key pieces of information. Now we're going to kind of pull them all together. So we're finally ready to learn about completing the square. This method has tons of uses. You're going to use it a ton in Algebra 2. But what we're going to work with today is dealing with quadratics that are in standard form, and we're going to be able to put them in vertex or shifted form. So we've got the quadratic, y equals x squared minus 4x minus 1, and it's graphed for us to the right. It says consider the binomial x squared minus 4. So what they're asking us to do is to consider the first 2 terms of our standard form. What would you need to add onto it to create a perfect square trinomial? And it says see exercise 3. So if we go back and we look at what we were doing in exercise 3. Well, exercise 3, we were taking half of the b term, we were squaring it, and that was giving us our c term. So if we go back and say, I need to take half of my b term and square it. So let's kind of work to the side here. I know that b is equal to -4. But if I take half of b which gives me -2, and now square that, that's going to be 4. So it says, what would you need to add onto it to create a perfect square trinomial? So we would need to, so now think about this for just a second. We can't just randomly add some number to an expression or to an equation and have that be an equivalent equation. So what we're going to need to do is we would have to subtract 4 in order to add 4, okay, because those would offset each other, right? So that ends up creating an equivalent equation, because if you add 4, in order to offset that and still make an equivalent equation, we're going to add 4. Now, some of you are like, what are you doing? I'm sure of it. That's okay. Stick with me, all right? So it says in order to add 0 to that binomial, that's what I was just talking about, being able to offset that, because you can't just randomly add some number to our expression and have that be okay or have that be equivalent. So it says, what should we subtract to offset? Oh, I jumped ahead. I was just answering A. That's okay. I just answered that one in that question. I totally apologize. I totally got excited and got ahead of myself. All right. There we go. I answered this. Oops. I am clearly a hot mess right now. Here we go. That was our answer to A. That's our answer to B. Okay. Now let's do something with it. Okay. So it says, using the method of completing the square, now rewrite this trinomial in an equivalent shifted form. Okay? So you're probably thinking, okay, how are we going to do that? So if my original equation is that, and in part A we said we had to add 4 to be able to create this perfect square trinomial. So watch what we're going to do. X squared minus 4x plus 4 minus 4 to offset, and then what was our original constant? -1. So I have not changed my equation at all. I have not changed the equivalency of it. I've just changed the way it looks. So now what we need to do is, let's look at this fine and dandy little perfect square trinomial that we just created. Now let's factor that into perfect square form. So what I have in brackets there, what does that factor into? Sum and product. It's going to multiply to +4 and add to -4. Two numbers that multiply to +4 and add to -4. Hopefully you're saying it's going to be x minus 2 times x minus 2. I'm going to save us that step, and I'm just going to put it in perfect square form. X minus 2 times x minus 2 is what x squared minus 4x plus 4 is. Now, finish it up. What is? Combine like terms. -4 minus 1. And that's -5. Winner, winner, chicken dinner. We have shifted form for our parabola. This is so exciting. I can't even stand it. So now, what's my vertex? My vertex is 2, -5. Okay? So, I'd be safe to say about 25% of you are like, yeah, I got that. And the other 75% of you are like, heck no. So let's talk here. So it says this procedure is known as an algorithm. Okay? In other words, it's a set of steps or a recipe. So here's the recipe for completing the square. So if our quadratic is in standard form, and right now our A is 1. Okay? It's a little bit of a game changer when our A changes to something other than 1, but we'll tackle that when the time comes. Okay? We take half of the B value, then we square it, and then we add and subtract it. So there's nothing better than good old skill and drill or skill and kill to get some practice. So we're going to do 3 of these, and then I'm going to have you try 3 of them on your own. All right? So let's take a look at A. I need to take this trinomial in standard form and put it in vertex form. So how do I start out? X squared plus 6x, and I'm going to shove that minus 2 way over there, because there's something that I need to add and subtract to this equation so I can make it a perfect square trinomial. So what does my recipe say? Take half of b. So my b is 6. If I take half of it, it's 3. And then what's the second step say? It says square it. So what is 3 squared? And hopefully you're all saying 9. So that's what we have to add and subtract. So plus 9 minus 9. Now group them. There's our perfect square trinomial. So I need to come up with 2 numbers that sum and product multiply to positive 9, but add to positive 6. So hopefully you are all saying x plus 3 times x plus 3, but we're going to write the shortcut or the perfect square form of it and say x plus 3 squared. Combine your like terms, negative 11. Now we have it in vertex form. And what is my vertex? My vertex is negative 3, negative 11. Okay, let's try, you're going to do B on your own. Let's try C. Okay, you ready? So let's rewrite it and shove that constant over to the end because we need to put it in vertex form. So start your recipe. Take half of B, which is negative 5. And what's it say to do to negative 5? It says square it. Negative 5 squared is 25. So you're going to add 25 and subtract 25. Now I put those in red to show you that that's really 0. So we haven't done anything different to the equation. The equivalency stays the same. So we group them. There's our perfect square trinomial. We think sum and product, and we get x, so 2 numbers that multiply to a positive 25 that combine to negative 10, and that's going to be negative 5 and negative 5, or take the shortcut and write the perfect square form of it, x minus 5 squared, combine like terms, plus 2. There it is, vertex form. What is the vertex of this? And it is 5, 2. Okay? So, you're going to do B, you're going to do D. Just know that your C is 0 there. Okay? These 2 guys are going to have fractions in them. But give them a try. Use your calculator to help you take half and square and all that kind of good stuff, and you're combining like terms. I might even throw in a little extra credit for those of you that can get E and F totally correct. All right, nice job, guys.